Hello and welcome to the BAIS3410 Switching Lab 2 video and documentation. Starting off, we'll cover section 1, which is the network, and we'll be just showing off our network diagram here. So I'll just let you take a look at that. Then after this, we'll head on to a video which shows our PC getting IPv6 as well as G1. So it's just going to be going through there and running the IP config commands to check that out. So that'll be the first section. After that, we will continue to show by pinging VLAN IPv6 G2 as well. So that'll just continue on through there. As you can see, we are running the ping commands, and you can see that there's very few packet loss there. So it seems everything's running correctly. And finally, quickly, we'll just be covering pinging IPv6 VLAN 15. So we'll just be doing that real quick. Just showing the ping there. And then finally, we'll move on to the IPv4 and DHCP release and renews. As you can see here, we've just opened up Wireshark, and we're going to be running the IP config release and renew commands and showing the network traffic over the network on that. So in our HSRP setup, we decided to set the standby timer to 15 milliseconds and the hold timer to 50 milliseconds. This way HSRP will transition to the secondary device almost instantly. That way the hello packets are sent every 15 milliseconds, and if nothing is received for 50 milliseconds, then it will immediately switch over to the failover device. That way we can control how fast we want these devices to use failover, and it can be adjusted at any time if we need it to. As you can see here, we are just going to show what it's like being paired with the regular standard timer settings, which are usually set to 3 seconds for the hello or standby timer and 10 seconds for the hold timer. Then we will be switching over to our custom standby timers.
The problem that we've introduced to our network is a DHCP starvation attack. This attack is caused by a malicious system sending fake DHCP requests to exhaust the DHCP pool, denying legitimate users from getting an IP address. To launch this attack, we are using a Kali machine and the tool Yersinia. Now in Yersinia, we are going to select Launch Attack and then go over to the DHCP tab. Now in this tab, we are going to select Sending Discovery Packets. This will flood our DHCP server with DHCP requests. let's see how our router is handling the attack. Using the show IP DHCP binding command, we can see what IP addresses have been assigned. And as we can see from the show results, every available IP address in our DHCP pool has been taken. Now, the attack on our network originated from here. We know this because the IP address identified it as originating from VLAN 15. The fake DHCP request then followed this path to get to our router, which is acting as our DHCP server. Thankfully, this attack was isolated only to VLAN 15. However, we want to ensure that these types of attacks can't happen again so that all VLANs can continue to function as intended. To prevent this kind of attack from happening on our network again, we're going to use the security feature DHCP snooping. DHCP snooping is a security feature that can validate DHCP messages received from untrusted hosts and filter out invalid messages. It can also limit the rate of DHCP traffic from all sources, create a binding database with information on untrusted hosts with least IP address, and utilize the binding database to validate additional requests from the untrusted host. This feature can be configured on a per VLAN basis and by default is disabled. On switch 2, we are going to enable DHCP snooping. To do this, we enter the command IP DHCP snooping VLAN 1520. This will enable DHCP snooping on VLAN 15 and 20. Now we have to go to the interfaces of these VLANs to enable additional settings. For this example though, we are only going on interface 13, which is on VLAN 15. Here, we are going to limit the rate of DHCP traffic using the command IP DHCP snooping limit rate 20. This will limit the rate of DHCP messages to 20. If there are more than 20 DHCP messages sent, the port should shut down. We are now going to test this by launching the same attack that we ran before. As you can see, DHCP snooping has worked and the port has been put into a down state. Thank you for taking the time to watch our video. We hope that the video has been informative.